Okay, ladies and gentlemen, today what we're going to learn about is images formed from curved mirrors. We know what happens when we have straight mirrors, but what happens when you have a curved mirror? Now, a good example of a curved mirror is a spoon. The back side of the spoon we're going to call a convex shape. And convex shape gives you a special image that is upright. The inside of a spoon, when you look at it in the morning when you're eating your Cheerios or Frosted Flakes or whatever it is you eat, you see an image that's upside down. Try it tomorrow morning if you don't believe me. That's known as a concave, because if you look at the inside of the spoon, it kind of looks like a cave. So we're going to talk about today specifically about how concave mirrors form their image. A concave mirror is an inwardly curved mirror surface that is a portion of a sphere that converges. Well, what the heck does that mean? Well, if we take a mirror and it curves like this, it almost looks like it's a sphere if you continued on that circle. And when light comes in, we're going to learn that that light gets converged at a point, almost like a magnifying glass, but on the same side that the light is coming in. There's a couple things that we're going to talk about. One thing's called the radius of curvature and center of curvature. Convex mirrors, on the other hand, they actually have an outward curve. So they look like this. So I'm going to draw my hashes here. So when light comes into this, what happens is that light diverges. It bounces off in opposite directions instead of converging. Converging means coming together. Diverging means separating it. So here's our two examples. Convex, which is diverging. Light comes in and it separates like so. Concave, light goes in and the light goes together. So let's see, make sure that you saw that. So convex goes in, diverges, concave comes in and converges on the same point. Okay, so convex, parallel rays diverge from each other. Concave, parallel rays converge towards each other. We have some applications of concave mirrors. For example, a satellite dish. All this transceiver right here, when all the satellite rays come in, they bounce in and they hit that receiver. So this is a converging mirror because all the rays are bouncing in towards the receiver that's on a satellite dish. Security mirrors are a good example of a convex mirror because when light goes in, it diverges away from each other and doesn't converge. And so you can see a larger area. It's also used at airports. If you wanted to look under something, it diverges the light so you can see more light. Now, we have to know some specific points of interest for us when we're talking about a concave mirror. The first thing that we need to know is we're going to put hashtags on here. I'll give you an image of this and you can just print this off. If you want to write it in your notes, you can as well. So this is the reflective surface here. We have an image which is just an arrow, and we have to label some certain things here. The blue dotted line is known as the principal axis. The object is the arrow. The center of curvature is right here, and we have something known as the focal point. So if we had, again, we'll talk about this a little bit further, but these are the main things that you need to know for this type of diagram. And finally, we have our vertex, which is located at the principal axis, and the mirror. Okay, on points of interest for a convex mirror, we have principal axis, object, vertex, focus, center of curvature, and so on. So here we go. So we have our object, and to find where that image is going to form, what we have to do is we have to draw some rays of light. And what we're going to do is we're going to draw our ray of light right from the top of our image right there. Okay? And what's going to happen is we are going to draw a straight line from the top of our object straight to the mirror, parallel to the principal axis. And then we're going to put it through the focal point. So if we take a look, our ray is going to go parallel to the principal axis and then go through the focal point. So all light rays, we realize when they go parallel, will go through our focal point. So if you hit any light ray that goes parallel in there, will go towards that focal point. Our next ray of light will be from the top of the object to the focus of the mirror. Okay, so we go through the focal point and it's going to do the opposite. It's going to go away parallel. Okay, so you really only need two light rays to show where the image is going to be. These light rays left the top of this arrow here, so therefore the top of the arrow is going to be located right at this point where these two lines cross. So, but we can do a third line just to make sure. The third line, the third rule you got to know is you go through the center of curvature, so leave the top of the arrow, go through the center of curvature, hit the mirror, and then it bounces directly back through the center of curvature. And you can see that all three lines intersect here. This means that the top of the arrow is going to be directly underneath. So let's take a look. Our image is directly underneath and it's inverted as well. So that image is upside down. Now it's real because this is what we consider on this side of the mirror. We consider this the real part of the world. When we look into that mirror, this is the virtual part of the world. So if we saw an image inside the mirror, then that would be a virtual image. But since we have an image forming on the same side as our object, it's in the real world, it's an inverted real image. So we can describe these images according to an acronym known as SALT. So we're going to describe that little arrow that was upside down in terms of its size. Its attitude, was it upright or upside down? Its location, was it in front or behind the mirror? And the type, was it real or virtual? So we're going to call this smaller because it's clearly smaller than the original image. It's inverted, it's upside down. It's in front of the mirror, and it's a real. So if it's in front of the mirror, this is the front, it's going to be in the real world. If it's behind the mirror, it's in the virtual world. So location in front of the mirror, it is a real image. And the type, yeah, there we go, that's it. So that's it for today, and then we're going to talk about what we do for a convex mirror in our next video.